Hello everybody. So for this video, I am going to talk about the different situations and problems in kinematics. Okay. So for the first one, I am going to talk about uniform motion. Okay. When we say uniform motion, the object is actually moving at a constant velocity. All right. So let us start by answering this problem. So, Alan leaves Lawag City at 8 a.m. to drive to Manila, 400 kilometers away. He travels at a steady 50 kilometers per hour. Beth leaves Lawag at 9 a.m. and drives a steady 60 kilometers per hour. The questions: who gets to Manila first? How long does the first to arrive have to wait for the second? Alright, so basically this problem talks about time. We are solving for the time when Alan and Beth, for Alan and Beth, okay? But they started at two different times, okay? So let us start by of course, this is kinematics. The size of the object does not matter. We are going to illustrate the object as a particle, So we have two point here. For the first one, position A. For the first position, about this one, this is position A. This is actually Lawag, okay? Okay, and position B, this is actually Manila. So both Alan and Beth travels from Lawag to Manila, and we know that the distance from Lawag to Manila is given in the problem. This is okay. If x o, our initial is 0, then x here is 400 kilometers. Okay, that's the common to both Alan and Beth. They both traveled 400 kilometers. Okay, so let us solve for the time Alan drove from Lawag to Manila. Remember, for uniform motion, there is only one equation that we use, okay, and that is the distance traveled. Okay, so the distance traveled is equal to the average velocity times the time elapsed. Okay, so we have distance is equal to the average velocity times delta t, or t, okay, the time elapsed. But since in this case we are solving for the time, then this equation becomes time is equal to the distance divided by the average velocity. Okay, so for Alan, the time is equal to the distance, the 400 kilometers, and then divide this by the velocity. The velocity of Alan is 50 kilometers per hour. So let us write 50 kilometers per hour, so that kilometers and kilometers will cancel out, and the time for Alan, okay, let us try to denote this as T sub A, the time of Alan. Okay, so let us so the time of Alan is 8 hours. Okay, so the time of Alan to drive from Lawag to Manila is 8 hours. Now, let us try to solve for the time of travel for Beth. Okay, so for Beth, the time, let's say denote this as T sub B, is equal to the distance, the same, 400 kilometers, divided by the average velocity of Beth. Okay, that's 60 kilometers per hour. So if we try to use our calculator, 400 divided by 60 we have 20 over 3. That's 6 and 2/3, right? 6 and 2/3 hours. Okay, let's try to write this in fraction. Okay, so that we will not have any error in rounding off. Now Alan started traveling at 8 a.m. Okay, so and Beth started traveling at 9. So there is a 1 hour difference. Okay, so Alan arrived in Manila at, okay, so this is Alan will arrive in Manila at that is exactly 8 hours. So 8 hours from 8 a.m. is 4 p.m., right? So 4 p.m. That's 8 to 4 p.m. That's 8 hours. Okay, while Beth arrives in Manila. Okay, Beth started at 9 a.m. and he traveled for 6 and 2/3 hour. Okay, we can actually write 6 and 2/3 hour in hours, minutes. 6 hours, 2/3 of an hour. Remember that 1/3 of an hour is 20 minutes, so 2/3 of an hour is 40 minutes. So we have 40 minutes. Okay, so that's 6 hours and 40 minutes. Therefore, Beth arrives in Manila at it started at 9. 3:40, right? So this is 3:40 p.m. Okay, so the first question for letter A, who gets to Manila first? The answer is Beth, because she arrives at 3:40 p.m. compared to Alan 4 p.m. And for letter B, how long does the first to arrive have to wait for the second? So the 3:40 and 4 p.m. the difference is 20 minutes. So therefore, the answer is 20 minutes. Okay, that's the answer for this problem. For this video, I am going to talk about constant acceleration motion in one dimension. Alright, so basically, in problems for constant acceleration, we are going to use the kinematical equations. Okay, so the kinematical equations are shown on the slide. So we have actually 5, but of course, we'll not do them at once. We're going to use appropriate equation for specific problems. All right. So there, you can memorize them. You can also try to derive one equation from the other or so. Okay. So, but for one, I would like I am more into memorization of these formulas. Okay. So let us answer problems. First one, the figure shows the velocity graph of a particle. Draw the particle's acceleration graph for the interval 0 seconds to 4 seconds. Give both axes appropriate numerical scale. Alright, so we have here a graph of velocity versus time. Right? So the x-axis is time in seconds, the y-axis or the vertical axis is the velocity in meters per second. Now, we are trying to graph the acceleration versus time. Okay, so we are going to graph acceleration versus time. So the horizontal axis would be the same as the time, and the vertical axis will be the acceleration. and the unit for acceleration is meters per second square. All right, and then since we are trying to graph the acceleration from 0 to 4 seconds, so let's start from the origin at 0 seconds and then at a regular interval until 4 seconds. Okay, let us try to look at the graph of the velocity and time. A horizontal line, a horizontal velocity indicates that from 0 seconds to 2 seconds, the velocity is 2 meters per second. Alright, so the velocity does not change. Remember that acceleration is the change in velocity over the change in time. The change in velocity over change in time, the change in velocity is the difference between the velocities at 2 points. Okay, so at these 2 points, the velocity is 2, and at this point, the velocity is also 2. So if we try to look at this equation, the change in velocity is 2 minus 2. The velocity does not change. So whatever the time, it's 2 minus 0. So we have 0 because we have a 0 change in velocity. That means that the acceleration from 0 seconds to 2 seconds is 0. So 0 until here, we have 0. Okay, I'm going to try to use another color for the graph. Okay, we have red. Okay, so from 0 seconds to 2 seconds, the acceleration is 0. Now what happens here is that there is already an acceleration from 2 seconds to 4 seconds. Alright, so let's try to use 2 points here. This first point here and the second point here. Basically, the acceleration of a line there is the slope of this line. Alright, because acceleration is the change in velocity over change in time. So if we are given a velocity versus time graph, and the graph of the velocity versus time is linear, a straight line, whatever the slope of that line, yun na yung acceleration. Okay, so but since we are talking about change in velocity over change in time, let us use the 2 points. This first point here is 4, 4. And this point here is 2, 2. Okay, because 4 and then 4, 2 here and then 2 there. Okay, using this formula, change in velocity is this 4 here minus 2 there. So that's 4 minus 2. And the time is 4 there and then 2 there. So that's another 4 minus 2. So we have 2 over 2, or that's basically 1 meters per second square. So since this is a straight line, so there is a uniform acceleration from 2 to 4, and that is 1. Okay, if this is 1, the acceleration is constant at 1. Okay, so that is now the graph of the acceleration versus time. All right. Let us try to answer this problem. The figure shows the velocity graph of a particle moving along the x-axis. Its initial position x sub 0 is equal to 2 meters at t sub 0 equals 0 seconds. At time equals 2 seconds, what are the particle's position, velocity, and acceleration? The given graph is the velocity versus time. Alright, so we know the velocity at each time. Alright, example, at this point, at time equals 0, the velocity is 0. Alright, so at this point, at time 1 second, the velocity is 2 meters per second. At time 2 seconds, the velocity is 4 meters per second. At time 3 seconds, the velocity is 6 meters per second. Alright, so we are solving for the position, the velocity, and acceleration at time 2 seconds. Alright, What do we know here? What can we get from the graph? We know that the initial velocity is equal to 0 meters per second, okay, because it started from 0, 0. All right. We can also know directly from the graph the velocity at time t equals 2 seconds, because this is the point. At time 2 seconds, the velocity is 4 meters per second. Okay, so later on, we do not need to solve for the velocity, letter B. Okay, what can we also get from the graph? We can also get the acceleration. Remember, the acceleration is the change in velocity over change in time. Okay, and this one is basically the slope of the velocity versus time graph if it is a straight line. Okay, so the slope of the line is to get this one, we just need to get 2 points, any 2 points. Okay, so let us get 2, 4, and 0, 0 right there. So that's basically 4 minus 0 over 2 minus 0. So we have 2 meters per second square. So we have 2 meters per second square as the acceleration of the object as shown on the velocity versus time graph. Okay, we also know we are also given x sub o. Based from the problem, we have x sub o is 2.0 meters, and the initial time is also 0 seconds. Okay, now the time, when time is equal to 2 seconds, for letter A, what is the position? If we try to go back to our list of formulas, there are 2 equations involving positions, the first one and the fourth one. If we try to use the first equation, we do not have any average velocity. At the fourth equation, we have all that are needed to solve for x, right? So we have x, so we can use the fourth equation. Okay, so we are going to use the fourth equation there. So we have x is equal to the initial x sub o plus vot plus 1/2 at squared. So we have the initial velocity times time plus half at squared. All right, so let's substitute. X sub 0 is 2 meters, 2.0 meters, plus the initial velocity we know is 0. Okay, so this term is 0 right there, and then plus 1/2, the acceleration is 2 meters per second square, and the time we are looking for is 2 seconds. Okay, 80 squared, so we squared that one. Okay, using our calculator, the answer is 6 meters. All right, so the position of the object at time 2 seconds is at 6 meters. All right, letter B, the velocity at time 2 seconds. Okay, as I said earlier, it's already shown on the graph that the velocity of the object at time 2 seconds is 4 meters per second. Okay, so the velocity at 2 seconds is equal to 4 meters per second. And for letter C, the acceleration, remember that the acceleration of this object is constant because the velocity versus time graph is a straight line. Okay, it does not change. The acceleration does not change at 2 meters per second. Okay, 2 meters per second square. Okay, 2 meters per second square. All right, so basically those are our answers for this problem. For this video, I am going to talk about freefall. And when we talk about freefall, this is an special constant acceleration motion. Okay, this is a constant acceleration because the acceleration due to gravity is constant all throughout the motion of a free fall. Okay, since this is a constant acceleration motion, we can still use itong mga formulas natin na ito. Pero may mga mag-iiba lang. Ang mga mag-iiba are our notations. Okay? Since for free fall, ang motion na is along the vertical direction. So, itong mga notation natin, for example, x, magiging y. Okay? So, yun lang naman. Yung x, magiging y na. Okay? So, you do not need to memorize another set of formulas. Ang mangyayari lang dito, kahit ito lang yung i-memorize ninyo, applicable na siya even for free fall. Okay? Ang mag-iba lang dyan is actually the notation. Pero, meron tayong mga ano dito. Meron tayong mga kailangang malaman muna before we can use the formula. Okay, the acceleration due to gravity is constant at negative 9.81 meters per second square, or in the English system, this is negative 32.2 feet per second square. This negative sign of the acceleration indicates that the acceleration is downward. Okay, downward yung acceleration natin. Alright, so okay na tayo dyan. We will take na downward palagi yung acceleration. And then let's have a notation for our motion. Example, this is the ground. Okay, this is our ground. And at the ground, let us all agree that this will be our y is 0. Ibig sabihin, that is our datum. Okay? Datum. That is our point of 0 position. Okay, when an object is above the ground, we have a positive position. But when the object is below the ground, we have a negative position. Example, if there is a building here and the object is above that building, an example, the building is 20 meters high, then the position of this object y is 20 meters because it is 20 meters above the ground. And another example, if there is a hole here and the hole is 10 meters deep and the object is in this hole at the bottom of the hole, therefore the y of this object is negative 10 meters because the object is 10 meters below the ground. Okay, so that is our notation for the position of object. Another one in velocity. Okay, velocity. If the velocity is upward, okay, now if an object is thrown upward, for example, then we have a positive velocity. Okay, so we have positive velocity. When an object is thrown downward, okay, or when the object is moving downward, then we have a negative velocity. Alright, so that is our notation for free fall. Remember, the acceleration is constant at negative 9.81 meters per second square or negative 32.2 feet per second square. Alright, so let us try to answer some problems. And we come up with y sub 0 is 78.5 meters. That means that the motion is started at a height of 78.5 meters. Basically, this is already the height of the tower. Alright? So, the motion is started at point A, the top of the tower, and ends at point B, the ground. Therefore, the height of the tower is where the initial motion started. That's 78.5 meters. Okay, let's try to answer letter B. What is the bearing's impact velocity? All right, so the velocity on the ground is the velocity at point B. Okay, so to answer this one, let us use the most basic formula. Velocity is velocity initial plus acceleration times time. Alright? So we know that the initial velocity is 0. Okay, so the velocity is 0 plus the acceleration is negative 9.81 meters per second square, and the time is 4 seconds. Okay, so the answer is just the product of 9.81 and 4, so we have 39.24 rounded to 1 decimal place. That's 39.2 meters per second. Okay, so this is now the impact velocity of the object. But this one will have a negative sign. Okay, we'll have a negative because this is negative 9.81, so we have a negative sign for the velocity. What does that mean? So this negative sign right here indicates direction. Okay, this is indicating direction, and it is downward. Okay, remember, when your answers contain negative, that means it is opposite your positive direction. Okay, so right here in this scenario, all upward motion are positive and all downward motion are negative. So if we get a value of velocity of negative 39.2, then the motion is downward, and that negative indicates a downward direction. So that's it for this problem. Let us answer this one. So a rock is tossed straight up with a speed of 20 meters per second. When it returns, it falls into a hole 10 meters deep. What is the rock's velocity as it hits the bottom of the hole? And how long is the rock in the air from the instant it is released until it hits the bottom of the hole? Okay, let's illustrate the problem. So this is the ground where the motion started. This is when y is equal to 0. Okay, and this object, this particle, goes upward. Okay, and there will come a point when the velocity 0 started going downward until it passes through the ground, and there is a hole here, okay, 10 meters deep, and it hits the bottom of the hole. Okay, so we have 3 points of interest right here, and let us try to state all the given. Okay, at the first point, say at point A, at point B, and at point C. At point A, the velocity, since this is thrown upward, the velocity is 20 meters per second. Okay, this is positive because it is upward. And we know that the y is 0. It's already stated there. We can write it. Y is 0. Okay, and the time, of course, is 0. That's the only variables that we need. At point B, what we know here is the velocity. The velocity, of course, is 0. At the highest point of motion, the velocity always comes to stop. Okay, the velocity is always 0 at the top of motion. Okay, yun lang yung alam natin kay point B. And for point C, okay, for point C, ang alam natin dito is the position. Okay, we know the position of point C. It's 10 meters below the ground. Therefore, the y is negative 10 meters. Okay, y is negative 10 meters. We do not know the time and we do not know the velocity. Okay, right. So the first one is the velocity of the rock as it hits the. So basically, we are solving for this one. Okay, so what is the velocity at point C? Now, to solve for problems like this, we only need 2 points. Dalawang points ang kailangan natin, ano? So, we can select A, B, or C. But of course, ang ano natin dito is point A because given yung velocity, given yung Y, given din yung t. Okay, so we choose points A and C. Okay, and we are solving for v. Okay, so that's the final velocity. So based from our kinematical equations, the given and then the unknown is v. So we can use, we don't know any time, so we can use equation 5, because equation 5 is the only equation that does not involve time. Okay, so let us use equation 5. Okay, so the velocity at c for part A, since we are looking for using points A and C, so this is A is our initial position, C is our final position. So our equation now becomes the velocity at C and then squared is equal to the velocity at A squared plus twice the acceleration times delta x. So that means that's the y, the position at C, minus the position at A. Okay, so that's 2a delta y. Okay, the position at C minus the position at A. Now we are solving for the velocity at C, so we can leave it like that. The velocity at A is given at 20 meters per second, so this is 20 meters per second square plus twice. Remember, this is a free fall. The value of the acceleration is negative 9.81 meters per second square. Okay, y sub c is the position at C. We know that's negative 10 meters, and the position at A is 0 meters. Okay, so 20 squared, that's 400, and then this is negative, that's negative, so this becomes, the whole thing becomes positive. Let's try to use our calculator right here. So we have 596.2. Okay, 596.2, and remember the left side of the equation is v sub c squared, so we need to take the square root to solve for the velocity at C. Okay, the square root is 24.4. Okay, so I have 24.4 meters per second. Okay. Okay, remember we took the square root right here. Okay, we took the square root right here. So v sub c squared, we took the square root, and the square root here, since we extracted the square root here, the answer can be positive or it can be negative. All right, it can be positive or it can be negative. Now your logic or your common sense should dictate that the velocity should be negative, because at point C the motion is downward, right? The motion is downward. Therefore we can say v sub c is negative 24.4 meters per second. Okay, so this is our velocity at point C. Now for letter B, how long is the rock in the air from the instant it is released until it hits the bottom of the hole? Okay, so for letter B, now we are solving for time. Now if we take a look at this one, we already know the velocity at A and velocity at C, and we know the acceleration. Now we can use the formula for acceleration to solve for the change in time. Okay, the time is just equal to the change in velocity over the acceleration. Okay, using this formula, the time, the change in velocity, velocity final minus velocity initial, we have v sub c minus v sub a all over the acceleration. Okay, so the velocity at C is already given at negative 24.4, that's meters per second, minus the velocity at A, that's positive 20 meters per second, and then divided by the negative 9.81 meters per second square. Okay, using our calculator, we can now solve this. Negative 24.4 minus 20 divided by negative 9.81, and we come up with 4.5 seconds. Okay, so this is now our answer for letter B. Okay, so that's it for this problem.